Hello, so
This call is now being recorded.
welcome to today's session. We are going to be covering financial application or financial functions in Excel. So, yeah, let's get right into it. So, there's so many applications that we can use to so many operations that we can use Excel in the financial sector. And that is something that we're now going to be looking into and just making sure that we are able to see how we can apply that. So the first thing I'm going to start with is just being able to calculate the payment of a loan based on constant payments and a constant interest rate. Okay, so this is something that basically happens in most institutions, from banks to even mobile loan apps. Though with mobile loan apps, there's no really main specification of having a constant payment, but for bank loans, we can see that principle applied a lot. So that is what you are going to do. So I'm going to be using use cases. That is just creating a scenario and then calculating using that scenario and calculating various aspects. You're going to look at loans with different durations, investment or annuity, compound interest, loan amortization schedule, depreciation, profit margin, and so much more. So it's going to be an interesting session. So the first scenario I'm going to use is we're going to consider a loan with an annual interest rate of 6%, a 20-year duration, a present value of 150,000 US dollars, that is the amount borrowed, and the future value of zero. That means that by the time you are finishing the loan, of course, paying the loan, you want it to be zero. So that's just the main point. So how do we do that? How do we do that? We use the PMT function in Excel, and that's what we have in our first row. And then we have our rate, which is our interest rate. And then NPAR basically just means the total number of periods, the total number of periods. And then we have the present value and the future value being FV. So in our case, we want to consider that loan and calculate the annual payments. I'm going to do it annually and then quarterly and monthly. So basically, first we're just going to start with the annual. So with the annual, we have been told that our interest rate is 6%. It is 6%. So that's just what you're going to have. And then our total number of period is in a 20-year duration, so 20 years. And then our present value is 150,000 US dollars. So that's just what I'm going to do. 150,000 US dollars. And then the future value, we want it to be zero. We want the loan to have been fully paid by that time. So I'm now going to insert a formula on the payment of the loan. So remember, we have talked about this before, that to just create a formula, you just start with an is equal sign. And then I'm just going to multiply those cells. You're going to multiply the rate to get that value. Okay, just prefer using capital. The rate, and then we'll have the total number of periods as well. So that is C2, and then we will have our D2, that is being the present value, and our future value. So the moment you input the formula. Okay, I'm sorry. What's happening? Okay, yeah. So the moment you input the formula PMT, it automatically there's an error somewhere. So let us E20, no, it's E20, E2. 6%, 20, 150,000, 0. Yeah, okay, let us increase the width. Okay. Oh yeah, it hasn't. I didn't input the formula PMT. The formula is PMT. So the moment you input that formula, it automatically calculates for you. Let me just highlight something. You can see there is a small instruction set telling you calculate the payment of loan based on the constant payment and constant interest rate, just like I talked about. And then you can see it gives you the value that you should put. You should put in the rate, the NPA, that is the total number of periods, and then the present value, then the future value. So that is just what we have done, and we have received our payment. We have received our annual payment. So our annual payment should be 13,000, roughly 13,000 100 US dollars, but you can just to be appropriate, I mean, to be specific, it's that specific figure. So that individual should pay, or we should pay that amount so that we can make sure that we have cleared our loan in 20 years at an interest rate of 6%. So what if we want to find the quarterly payment? This is the annual payment. So you're paying this for 20 years and your loan is acquiring or gaining an interest of 6%. What if you want to find out if what will happen if you want to make quarterly payments? So of course it's going to be, the rate is going to be divided by 4, making that to be around 1.50. So that is what we're going to start with, 1.50%. And then the number of period is going to be 20 times 4. So that is going to be 80. And then the amount remains. The present amount does not change. And then the future value, of course, we want it to be 0. So I will just come ahead and say is equals to, or even without me having to do that, remember when we talked about flash fill? So it will just do that. If you use the cursor and drop it to the next line, you can see it gives us the amount that should be paid quarterly, and that's around 3,232.25. So that is the amount that should be paid quarterly. What if you want to calculate the monthly payment? The monthly payment. So of course it's going to be the 6% divided by 12, making that to be 0.5%. And then the payment now is going to be 20 times 12, which is around 240. Not around, it's actually 240. The present value of the amount still remains to be 150,000. Future value is 0. Okay. So what is going to be the monthly payment to be made? So just by dropping this down. So this flash fills the formula automatically. So you can see it's around 1,074.65 US dollars. Yeah. So that is that. What if you want to consider an investment with an annual rate of 8% and a present value of zero? So this is an investment. Of course, investment starts from the account initially has nothing, and then as you invest, it gains. As for a loan, you start with the money, and then when you're paying off the amount, the money now, the account or that amount is considered to go towards the zero. But for an investment, is from zero growing. So let us consider an investment with an annual interest rate of 8%, present value of zero. How much money should you deposit at the end of each year to have 1,448.66 dollars in the account in 10 years? How much money? So it's still a payment, it's still a PMT. So what will happen? You'll just have our rate being 8%. 8%. Our duration, our duration is 10 years. Our present value is zero, and then our future value is, so the future value can be anything. So for this specific scenario, they gave us that. Okay. Yeah. So what will be the payments that will be made, or the investment or the amounts that should be deposited in that account so that you can have that amount? So I can still flash fill, though of course for self, for row 5 it will be, there'll be no amount, so we can just delete that. Yeah, so you can see it will be $100. $100 should be deposited for 10 years in an account that has an interest rate of 8%, so that eventually you can have 1,440 $448.66. I'm going to look more into investments in just a few. We can just look into it. Let me touch on investments and annuity. Let me just give a short example and annuity, and then I will get into both of them at once. Okay. So annuity. So we are going to consider an annuity with an annual interest rate of 6% and a present value of, so it has an annual interest rate of 6%, with a present value. So the present value is $83, 83,000 $748.46. Okay, 0.46. That is the purchase value. How much money can you withdraw at the end of each month for the next 20 years? For the next 20 years. So I believe this is like, okay, so of course the future value here is going to be zero, because you want to consider, or you want to find out how much money will you be able to withdraw every year, or consider an annual interest rate of 6% annual, and then the present value is that how much money can you withdraw at the end of each month. So first we're going to divide our interest rate, by 12 to have 0.50. So this is the annual, so I want it to be 0.50%. And then we are going to, since it was for the next 20 years, but we are finding out monthly, so it will be 20 by 12, making that to be 240. Okay, so we want to find out how much money we can withdraw monthly so that this present value can get to zero, and do that in a duration of 240 months or 20 years for that case. So same formula, same PMT. So if I just do the flash fill, we can see around $600. Remember, the account is giving you an interest, so with that consideration, yeah. So it's you, as much as you're going to be using your money is still gaining some value. It is still gaining some value. Before I move on to finding out the principal and the interest, and finding and calculating the interest, I want us to look more into the investment and annuity. I want us to get a little bit deeper into investment and annuity. So, okay. So, we are going to also just take an example and then use that. So, our example, I'm just going to write it here. We are going to have, so like I skipped this part, so I'll just write it quickly. Annual interest rate. Okay. Annual interest rate. And then, okay, just think, can just increase the width to make that fit properly. Yeah. And then years. And then next, you're going to have yearly payments. And then you're going to have future value. Future value. Okay. So we're going to have an annual interest rate of 8%. Okay. 8%. Years 10. Yearly payment 100. $100. Yeah, so we want to calculate the future value. We want to calculate the future value. So assume that at the end of every year, you deposit $100 in a saving account at an annual interest rate of 8%. How much will your investment be after 10 years? That is what we are trying to calculate. So what happens, you just come in this button, right, is equals to FV. So you can actually say that it gives us a small pop-up, returns the future value of an investment based on periodic constant payment and constant interest rate. So for my case is I2, okay, sorry, I2, comma, I, I3, comma, I4, I4. Okay, so I'm just going to increase the width so that you can see the amount well. So when you get the hash, just means that the width of your column is a little bit small, so just increase it. So you can see it's 1,448.66 what we had here. Okay, so for annuity, you're now calculating the present value. You're calculating the present value. So it's just the same breakdown. I can just write it here. So annual interest rate is 6%. Years is 20, and then monthly payment is $600. $600. So I can just write here present. Okay, so with that I can just extend this column just to make that look reasonable. So of course now it's going to be is equals to PV in this case, PV, and then so you can actually see without that it returns the present value of an investment, the total amount that the series of future payments and etc. So it tells us that you should put in the rate. So my rate is K2. My total number of periods is 20. Okay. So the question is, assume you want to purchase an annuity that will pay $600 per a month for the next 20 years at an annual interest rate of 6%. Okay, so the 600 is monthly. How much does the annuity cost? So what I'm going to do is I'm going to divide the interest rate by 12. Okay, and then I am going to multiply the years by 12 so that you can get it in monthly and then not use the monthly payment as is. So I'm just going to come ahead and try and divide K2 by 12, then multiply K3 by 12 as well, and then K4. Okay, so with that, let me just increase the width. Yeah, so that is our annuity value, 83, 83,748.46 dollars. So that is the cost of our annuity. That is the cost of our annuity. Okay, I just wanna also look at we have already looked at PMT, that is just calculating the monthly payments. So I want us to look at PPMT. So it calculates the principal part of the payment. So for example, I can just write it here, principal. So these are just my headers, principal, and then rates, and then NPA, and then PV and FV. Okay, so our principal, so we want to calculate the principal part of a payment. So I'm going to first assume that we have been given a loan with an annual interest rate of 5%, a 2-year duration, and a present value of 20,000. 20,000. So that's the amount value borrowed. So this is $20,000 and 2-year duration, and it has an annual rate of 5%. So we want to calculate the principal part of the payment. So I'm going to use monthly. So I'm just going to come ahead and okay, I'm going to divide 5 by 12, making that to be, because our rate is 5%. So when I multiply the 5%, it's going to be 0.42%. It's a 2-year duration, so 2 by 12, that is 24. So of course, our future value, when you're paying a loan, you expect to finish everything. So you want to find the principal part, but I want to be specific. If I just type is equals to PPMT, you can see it tells us returns the payment of the principal for a given investment based on periodic constant payments and constant interest rates. Okay, let me just put that in caps. PMT, of course, it's not compulsory, just like we have seen, but I just want us to be specific and just clear. So the rate is in B10. Now, here there's a trick. Principal means the amount that you pay to service the loan. Um, of course, if I just calculate the monthly payment, I'm going to get a specific value. But if I want to find the principal, that amount changes during the course of you paying the loan. You know, it's not like if I have a loan that is being serviced over 5 months, I don't expect to pay the same thing I was paying on the third month or on the second month, like what I was paying on the first month, because I have reduced that amount. As much as it is earning interest, once I pay the first time, I have reduced that amount in a way. So what if you want to find the principal part of the fifth payment or of the fourth or the third? So for my case, let me find the principal payment of the fifth payment and then come ahead and now do the rest. So we have now our C10, that is for NPAR, as you can see even from the formula, and then we go ahead to PV, which is D10, and then we now have our FV. We now have our FD, which is E10. E10. Okay. So yeah, so you can see that the amount is 827.21. Let us see if you had used the PMT function to just calculate the monthly payment, what it would have given you. Let us see what it would have given you. So I just want to copy those values. Don't need to rewrite them. Yeah, so but the formula is different. So PMT, the monthly. So I want to find the monthly payment. So of course I'm going to use the same variables, but now we're just going to say B11, C11, D11, and now E11. So You can see what that gives at 877.79. So you can see the values are different. So this was for the fifth payment, or the principal of the fifth payment, but this is monthly payment in general, just going to give you that directly. Okay, let me just do something. Okay, so let us now calculate the interest part of the payment. The interest part of the payment. Let us calculate that. So I'm just going to use the same values here. Okay, so I want to calculate what's the interest part of the fifth payment. So at the end of the day, when you're servicing a loan or when you're paying for a loan, you normally pay the principal and the interest. Okay, so even just from the difference here, you can directly see what our interest is, but you can also just calculate it. So to calculate it, I'm just going to say is equals to IPMT. But I want for the fifth payment, the principal for the fifth payment. I mean the interest for the fifth payment. So to do that, I have IPMT. I want to have, you can even see it's telling you put in the rate. So our rate is B12. And then since I want for the fifth, I have to specify that. And then I go ahead now to my total number of periods, that is C12. And then we go ahead to B12. And then we go ahead to E12. Okay. So once I click that, you can see that the interest part is $70.58. So that is what is happening. Okay, so that is that. I want us to see how we are going to compare. Remember, we have been doing loans which have constant payments and constant interest rates. So what if our loans have different durations? How do we do that in Excel? How do we do that in Excel? So I'm just going to open a new sheet. So I had already written the headers, annual interest rates, years, amount, and monthly payments, as well as the total paid. So we are going to look at a scenario where we calculate the monthly payment on a loan with an annual interest rate of 6%. So our annual interest rate is 6%. And then 20-year duration. So here it's 20. And then the amount borrowed is $150. 150. Okay. 150,000. So we want to find out the monthly payment. So this is something that we have been doing using the PMT. So that's just direct. So remember, it is monthly. So of course, our annual interest rate shall be divided by 12. So A2 shall be divided by 12. And then we'll have the years multiplied by 12. So B2 shall be multiplied by 12. And then we will now have the amount. So you can see that is our monthly payment. 1000 1074 and 65 cents. So let us change the durations of our loan. Let us change the duration of our loan. So the interest shall be the same, but the duration shall be different. So I want to put two different durations. So here will be 25, and for this we will have 30. The amount is still going to be the same. Yeah, so we can also just apply the formula. So you can see what is happening. It's now 966.45 and 899.33 dollars for each. So that's the monthly payment of 25 years and as well as 30 years. Let me just make sure this is single. Yeah. So let us find how much money was paid for each loan. What's the total amount paid for each loan? So I can come on and say we are going to multiply the years or the duration by the monthly payment. So our duration is in years, so we are going to turn that into monthly and then multiply with the monthly payment. So that is 20 no b4 b4 times 12 times d no d2. I've confused that too. This should be 2 b2 b2. Okay, so just increase the width. So yeah, we can see what has happened. That is the total amount paid for each loan, and we can see the one for 30 years, you pay more. And this is a strategy that is actually implemented with mortgage payments. This is a strategy that is implemented with mortgage payment. You can see if the duration is less, the amount is less. Than if the duration is more, the amount is more. Of which, of course, yeah, since the interest is uh, um, occurring monthly or yearly, depending. Okay, so we are going to look at, oh, this is what I was looking for before. But we have already done investments or annuity. We have already done investments or annuity. Don't need to repeat that. So we are going to look at compound interest. Compound interest. So of course, this is a term that is so directly that is going to be 100 and 108. But let us see how that is calculated. Let us see how that is calculated. So in case we have so I'm just going to calculate this here. So in case we have $100, in our account, in our bank, and you have been told that the investment is worth has an interest rate of 8%. So what's the investment? So I'm just going to say it's equals to A1 times 1.08. Yeah. So wait, something is not right here. A1 times 1.08. Oh, not A1. Supposed to be I1. Sorry about that. Yeah, so that's the for the first year. So what if you're told according to compound interest, how much will your investment be after 2 years with an annual investment of 0 point still 8%? So you're just going to multiply the A2. I'm going to say A2 times 1.08. I keep saying A2, it's I2. I2. So we can see what has happened. So if you want to find out what about in 5 years, since we have a formula, so I'm trying to just build this up. Okay, yeah, perfect. So we can see what the amount will be. So if you want for the fifth year, it's gonna be 146.93. It's gonna be 146.93, of which this can still be attained by multiplying I1 by 1.085 times. 1.085 times. Or you can come ahead and yeah, you can say 1.05 raised to power 5, which you can see it still gives you 146.93. So, in case you have put $100 in your account and you want to know how much your investment will be worth after 5 years at an annual interest rate of 8%, you just go ahead and say, so the principal is $100, and then the annual interest rate is 8%, and then compounding periods per year is 1, and then the years are 5, and then what is the amount? And so I'm just going to say is equals to B2, which is the annual interest rate, um, times 1, okay, sorry, 1 plus compounding period per year, so that is B3, divided by, um, no, the, sorry, B3 is the annual interest rate. Wait, no, this should be B1, the principal multiplied by the annual interest rate, 1 plus the annual interest rate over the compounding period per year. So this should be B2. B2, so this should be B2 divided by B3, close that bracket, raised, um, okay. So we have divided by the compounding period per year. So we want to multiply the compounding period per year by the number of years. So it's going to be B3 times B4. B3 time, sorry, B3 times B4. So with that, you can see that the amount earned is 146.93, which is just what we got before. So we can look at another example. So assume you put 10,000 into a bank. So that's definitely our principal. So 10,000. And then you have an annual interest rate of 4%. And then you have a compounding period of 4. And then the years are 15. So remember, some interests are compounded after 4 years, 2 years, 1 year. Basically depends with the agreements that you have with the bank or whichever institution you invest in your money in. So we want to calculate the amount and we want to calculate the amount and. So of course we're just going to use the same formula, which if I'm not wrong, I should be able to flash fill that. Yeah, and I get it directly. So it's going to be 18,166.94. So yeah, so we can look at one more example. So assume you put 10,000 into the bank, 10,000, and then you have an annual interest rate of 5%, and then you have a compounding period per year is 12, and then the years are 10. So what is the amount? And so just overflow that and increase the length of our column width, and you can see it is 16,490. So this is compounded after every 12 years. Compounding periods per years are 12, not 12 years. So this is like quarterly. This is once a year, so it's compounded once in a year. For 5 years, this is compounded quarterly. For 15 years, this is compounded every month for 10 years. And I believe this is a strategy that is used mostly by banks when they are giving you loans. They compound that yearly, I mean monthly. Yeah, so you can see it gives them a higher return than if it was compounded quarterly or annually. So that is that. So we are now going to look at something we call compound annual growth rate. So I'm just going to go to a new sheet. I'm going to increase the width and I'm going to zoom in. So compound annual growth rate, CAGR. So we're going to, so this is calculating the compound annual growth rate of an investment over a period of years. So we're going to use a function, an RRI function. So, so we're going to start with the year, and then we'll have the value. So this is going to be 0, 1, 2, 3, 4, 5, and then this is going to be 100, 123, 125, 126, 134, 147. So we want to calculate the compound annual rate. So compound annual growth rate, compound annual growth rate. So to do that, I will use is equals an RRI formula. So it gives us a quick pop-up which says it returns an equivalent interest rate for the growth of an investment. So Excel does not have a formula for us to get the compound annual growth rate directly, so we use the RRI, okay? So where the RRI has three arguments, that is the number of years or the total number of periods, the start, that is the present value, and the future value. So our present value, okay, the number of years are 5, that is something we can see directly. And then the present value is 100, and then the future value is 147, or the end, the start and the end. So we are going to start with 5. So that is A7, comma, the first value is B2, comma, B7, B7. So with that being said, we can see what our value is, 0.08. So multiply by 100, that gets to 8%. 8%. So the compound annual growth rate measures the growth of an investment as it had grown at a steady rate on an annual compounded basis. So it's just the same as saying 100. If you have 100 here and we want to find the CAGR at this point, we can, and for the 5 years, we can just easily say is equals to D1 times 1.08. So since we already know the rate, that is around 8%, that is by multiplying this by 100. So with that information, we can easily know that thing is not done correctly here. DDI times loans. D1, sorry, D1. No, it's D2. It's supposed to be D2. So you can see with that it gives us the 146.93, which is roughly 147. So that is that. That is our CAGR. So let us look at the loan amortization schedule. Let us look at the loan amortization schedule. So I'm just going to increase I'm going to zoom out to make sure you're able to see. Okay, so we have so we will use the PMT function to calculate the monthly payment of a loan with an annual interest rate of 5%, a 2-year duration, and a present value of $20,000. So our annual interest rate is 5%. We have a 2-year duration, payment per year 12. Since you're paying monthly, so there are 12 payments per year, and then the amount is 20,000. So let us first start with the first payment. What will be the first payment? So here we shall use the PMT function. So we're just going to come ahead and say PMT. So this is something we have done. So we are going to start with the annual interest rate. Since you're finding it for monthly, we're going to divide the annual interest rate by 12, multiply by years by 2, and get the amount. Okay, so we're going to start with our annual interest rate is at B1. So B1 divided by 12, comma, the years now, that is our B2 multiplied by 12, and the amount, so that is 20,000. That is just going to be directly B4. So we can see that the first payment, monthly payment, shall be $877.43. Let us now use the PPMT function to calculate the principal part of the payment. So yeah, so I'm just going to write is equals to PPMT, and then you're going to calculate the annual interest rate, that is in B1, divided by payment per year, divided by payment per year, that is B3, the 12 payment. So you're definitely dividing that by the number of years. So I don't have to specify that to be 12. Yeah, it's already there. And then comma. So I'm finding the principal for the first payment. So the first payment, I've already highlighted it as this as A7. So I'm just going to pick that directly, A7. And then I'm going to pick now the years multiplied by the payments. per year. So multiply just the years by 12. So it's going to be B2 times B3. Okay. And then we're now going to have the amount that is going to be B4. So that will have that will be 7. That will be the principal of the first. So you can easily find the interest by subtracting, but let us just use the formula, the IPMT. I'm going to put this equals IPMT. We're going now to have our rate. So same thing, B1 divided by B3, comma, since it's for the first year, is 7, comma, years, that is B2 multiplied by payments per years, that is B3, comma, B4. So you can see that is our interest. That is our interest. So what will be the balance? The balance shall be the so the balance is going to be wait um, yeah, shall be the amount that is before yeah, plus the principal, plus the principal. Does increase the width. Yeah. So whatever has a bracket is usually a negative value, even in accounting. So that's why when you just take the amount minus the principal, it automatically subtracts that value. Okay. So that's the balance you have for your loan. So we can now go ahead and do this for the second part. Okay, it's going to be 2. Mm-hmm. Just something. Let me try something. I'm trying to autofill this. Let me see if it will cooperate with me. Okay. Okay, I need to give it a system. So let me just first give it a system, then we see if it will follow it up. So annual interest rate is going to be B1, and then divided by 12. So this is going to be the years B2. This is going to still be B4. Okay, so So this is going to be still B1 divided by the payment per year, which is still B3, and then A8, that's okay. And then this is still going to be years, which is B2. This is going to be payment per year, which is B3, and then the amount B4. Yeah, so we're now going to do the interest, annual interest rate, that is B1, divided by payments per year, B3. So it has incremented everything by 1, hence the error, multiplied by payments per year, B3. And this is going to be, the amount is B4. Okay, so this is still going to be B4 plus C8. No, it's not going to be like this. It's going to be this amount, not this amount anymore. It's going to be E7 plus C8. Yeah, yeah, that's okay now. So let us see if it will accept to flash fill. Let's see. This is not cooperating. I thought it's gonna make the work easier for me, but it is not accepting. It is not cooperating with me. It So I don't know why my Excel is not cooperating with me, or probably I'm just doing something wrong. I wanted it to autofill until our balance is zero. That is the goal. That's why I'm trying. I keep trying to autofill just to avoid the hassle of having to write each and every line of code. Just to E8 plus, no, yeah, E8 plus C9. Yeah. No, was it accepted at that point? And oh no. Let me try. Already, I am in denial that I cannot be able to flash fill this. Just run a new. Let's see what will happen. Understood. Okay.